Allow me to choose the next one now, and then you will choose the following. A spherical balloon is expanding. Its radius increasing by 0.5 centimeters per minute. Find the rate at which its surface area is changing at the moment when the radius is such and such. Since we talked about volume and radius, let's talk about radius and surface area. And then you'll choose the next one. So that's 25. So it's expanding, its radius increasing meaning the rate of change is positive. So the radius is dr over dt, increasing by, if it says centimeter per minute, I know it's a rate of change because it's 2 measurement units, centimeter per minute. So then I know that dr over dt is 0.5 centimeters per minute. This is the first piece that I obtained by reading the problem. Then, find the rate at which its surface area is changing when. So find dA over dt when the radius is, I think it said 40, isn't it? Yes, I'm pretty sure. 40 centimeters. Good. They even give us the area. So this is 4 pi r squared. So this is the relationship between the functions. A is a function of time, radius is a function of time. What are the functions? Because we're pumping air into this spherical balloon. And the radius is changing and the surface area is changing. And they're asking us to find the rate of change of the area with respect to time at the instant in which the radius is 40. Well, I cannot use this till I determine the relationship between dA over dt and dr over dt, and then I plug in the information. Okay, so I'll differentiate implicitly. So this is dA over dt, and this is 8 pi r times the inner function prime. Now, I don't have to solve for anything because it's already solved. I'm asked to find dA over dt. Okay, here it is. When the radius is 40. So this is 40 and this is 0.5. So dA over dt equals 8 times pi times 40 times 0.5 times. Okay, good. So let's see what we get. 8 pi multiplied by 40 times 0.5 is 20 because it's 40 times 1/2, but that's okay. Times 0.5. Okay, so 502. So dA over dt is 502.65. 502.65. Okay, measurement unit. Can anyone give us the measurement unit? 502.65. What is the measurement unit of this? Please. Measurement unit. Anyone?
Centimeters per minute.
You're correct with the minute, but because it's area, it's centimeters squared per minute. Good, very good. Okay, very good. Let's take a look. I like to look at also the large cube or the cube type of problem. And then something about sales, revenue, profit. Uh, 27. An ice cube is melting. Each side is shrinking. Shrinking meaning a negative rate of change. 0.8 by 0.8 centimeter per minute. So if I have a cube, I'm going to say the side is denoted by x. So dx over dt is shrinking. And again, it's at 0.8 centimeter per minute. 0.8 centimeter per minute. Okay. Good. That's what we have so far. Find the rate at which the volume is changing at the moment when the length of an edge is 20. So find dv over dt exactly when the side is 20 centimeters. Assume that the cube maintains its shape. Very important. Okay. Does anyone remember, because I have to start with the volume, does anyone remember the volume of a cube? Volume of a cube. Anyone remembers the volume of a cube?
With a cube.
Yes. Very good. We have the relationship between two functions, function of time, function of time. We differentiate dv over dt equals 3x squared times the inner function prime. And we're asked, we don't have to solve for anything, it's already solved. We're asked to find dv over dt when x is 20. And this is given to us as negative 0.8. So then dv over dt, oops, is 3 times 20 squared, which is 400, and times 0.8, but I cannot forget the answer has to be negative. So the answer is negative 960, measurement unit.
Is it centimeters cubed per minute?
Thank you very much. Why centimeter cubes? Because this is volume. Perfect. Excellent. Thank you. Great job. Good. Okay, so now let's look at something. Find the rates of change of total revenue, cost, and profit with respect to time. When ta 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 ta. So let's look at a problem like this and then move on. Anyone would like to choose, or I will? Okay, I'll choose 35. We are given r of x equals 280x minus 0.4x squared. We are given c of x, 5,000 plus 0.6x squared. And when x is 200, dx over dt equals 300 units per day, obviously, to measurement units for the rate of change. So let's read the question one more time. Find the rates of change of total revenue, cost, and profit with respect to time. Assume that R of x and C of x are in dollars for the measurement unit. That's very important. Okay. So let's first determine the profit. And we remember that the profit is revenue minus cost, total revenue minus total cost. Careful here because you have to subtract all terms in C of x. So here's the revenue, 280x minus 0.4x squared, but minus 5,000 and minus 0.6x squared. Because of the negative in front of the cost function, we have to make sure that we subtract both terms. Good. I'm going to try and simplify it a little bit. So the negative 0.6 and with the negative 0.4 is negative x squared. Then I have plus 280x and minus 5,000. So now let's start with the revenue. I'm going to copy it here. So first we have the revenue equals 280x minus 0.4x squared. Remember that x is a function of time. So this is a function of time, this is a function of time. So dr over dt equals 280 times x prime, but x is a function of time, so it's dx over dt. Bring 2, and I have negative 0.8 times x times the inner function prime, which is dx over dt. I determine the rate of change of r. Now I have to plug in. I have to plug in as this, as being 300, and this as being 200. And that would be dr over dt. So, $280 times 300 minus 0.8 times 200 times 300. So it's 3,600. Can anyone give us the measurement unit? X is in units, and we were told that revenue, cost, and profit are all in dollars. What will be the measurement unit of dr over dt? Measurement unit of dr over dt. Anyone, please?
Dollars per unit.
Of course. Good. Now we continue with the cost. So C of x is 5,000 plus 0.6x squared. So therefore, dc over dt equals, this is 0 when we differentiate, but this is 1.2 times x times dx over dt. This gets replaced by 200, and this gets replaced by 300. So therefore, 1.2 times 200 times 300 is 72,000. And of course, dollar per unit. and profit. Here it is. dp over dt, negative 2x plus 280. Negative 2x dx over dt. Sorry, I rushed. Times dx over dt. So negative 2 times x times dx over dt plus 280 times dx over dt. Okay. There was 200 and this 300 units per day. Sorry. Good. Okay, so let's multiply. So this x was 200, and this is 300, and this is 300. And let's see what we get. Negative 2 times 200 times 300, and then plus 280 multiplied by 300. Okay. So the cost was 72,000. The revenue was 3,600, and now the profit is negative 3,600. It's a little bit weird. Because they are losing money. So this was, okay, 280x minus 0.4x squared, 5,000 plus 0.6x squared when x is 200, 300 units per day. Okay, I'm checking my numbers. So I think I copied everything correctly. 280, yep. So it's 280 times dx over dt minus 0.8 times x dx over dt. So I'm checking my calculations again, just to make sure that I don't have an error. 280, yes, times 300, yes, minus 0.8 times 200 times 300, yes. Then the cost, 1.2 times x times dx over dt. Yes, that's correct. And finally, if these two are correct, the third one is correct as well. So so these are the rates of change. So this doesn't say anything about profit or cost or revenue. This is how it changes when they produce 200 units. That's the change. So the change per day is 36,000 for the revenue. It's increasing. The cost is also increasing at 72,000. And the profit, the rate of change of the profit per day when they manufacture 200 units is this. That's the rate of change. Now, one thing I wanted to mention next is our test is next Tuesday. And I want to make a list. Which page am I on? I'm on page 12. I want to make a list of topics that I would like you to review between now and Thursday, and tell me what you need most of. So number one is graphing. Number two, I'm going through the topics that because I like to have a summary for you. So as you know, graphing, do not forget the table. Without the table, don't copy the graph from the graphing calculator, please. Max min on a closed interval. Okay. Rational functions. With the asymptotes and everything. Not the slant asymptote, but determining the slant asymptote, yes. I already mentioned that. Optimization. Which means max min for word problems. Okay. Okay, marginals. Linearization. And differentials. Six, implicit differentiation. And number 7, related rates. I cannot think of anything else.